Hi, pre-cal students. This is going to be for people who feel like they need to be reminded about what this is, or if you weren't here when we talked about it. So I'm just going to go through what this is, what it means, and what we did with this. That's what this video is. Okay, so if we are given SSA information, meaning we know, let's say I know I have this side length, and I've got that angle measure. That would be angle side side. So if you are given this type of information of a triangle, then it's possible that you wind up with this situation where there are exactly two possible ways to complete the triangle, right? In other words, if I have that angle and that side length, and the opposite side is the length of A, the A could go there or there. And that makes a big difference. If the A is over here, that makes the third side from here to here instead of from here to here. So that's a totally different length for the third side, and the angles are totally different too. That's not the same as that, and so forth. So it's an altogether different triangle, starting, however, with the exact same angle side information. Okay, but in order for that to happen, A has to be acute, and A, the side A, has to be in between the values of B, which is greater than it, and the value of, and H, which is the altitude right there, the height. And remember that we can get H by multiplying B times the sine of A, just because of SOHCAHTOA here, or the law of science, however you want to think about it. But H is just equal to B times the sine of A. So B times the sine of A has to be less, sorry, let me say it again. B times the sine of angle A has to be less than side A, which has to then be less than side B, in order for this to occur. Now, all these other things are possible, and in fact, what we found in class was that there were even a couple more possible cases if you start with this type of information. There are even other cases that are not covered by this chart. But what I had here as an exercise was to go through in each one of these setups and figure out which one of these cases we would have. And this is similar to what you'd see on a test. So you can take this information and say, well, if I've got an angle of 40 degrees, side opposite is 24, and there's another side of length 100, which of these are we talking about? Which of these cases? So A is acute, so it's not these two, and side A is less than B, and so it's not that one. And so we don't know if A then is less than H or equal to H or greater than H. So we just have to find H. So H is equal to B times the sine of A, and we can say that's 100 times the sine of 24, and I seem to remember that was 64. And I had a calculator a second ago here. I'm going to pause this thing. Okay, we're back. So we've got 100 times the sine of 24. No, what is it? 40. Oh, I screwed this up. Okay, 100 times the sine of 40. There we go. 40 was the angle measure. 64.3, we'll say, degrees. Okay, so obviously we could say that A is not equal to H, so it's not that one. A is in fact less than H, so clearly we're here. Okay, so that says A is acute, A is less than H, so there's no way for this to work. And we showed with a diagram in class why that's going to happen, but look, this is what happens, and they're actually showing it pretty well here. We don't know how long this side is, but this point, the end point of A, has to connect to this dotted line somewhere for this triangle to be complete. But it's not going to be able to reach because it's not long enough, because it's actually less than the direct distance of the altitude, which is what H is. So if H is 64 and A is only 24, this thing doesn't have a prayer of getting all the way down to the bottom line here and making this a triangle. So there's no triangle possible. Okay. Now this one, I've got an obtuse angle. So I'm over here, and A is less than B, and I'm here already, and that's none. So this is also no possible triangles, and we can see again, A less than B with that giant angle there, well, yeah, it's just, I mean, I could swing that thing around in a whole circle. It would never cross the dotted line. For this one, acute angle, A is greater than B, so maybe we're automatically there. Okay, so that's one possible triangle. There's no other way to do it. And this one was the ambiguous case. I think in this case, you had, I'm trying to remember what the, well, anyway, we could just figure it out. We could say B times the sine of 25 is equal to, okay, 55 approximately. All right, and so we definitely have an H of 55, which is less than A, which is 110, which is less than B, 130. So this is the deal with the fourth one. Now keep in mind, I'm keeping the names really consistent, but I could call them anything. I mean, suppose I had called this angle, I don't know, Q, and side Q, and side M. All right, well, that's fine, right? You could still say, okay, well, that is the side opposite from this angle, and that's just some other side. So if I drew a picture, I could say that that was angle Q, and that was side Q, and that was side M. The point is that this side is across from that angle, so this has to be side-side angle information. Now this last one, A is acute, right? However, A is not greater than B because it's equal to it. A is not less than B. And H, I think H ends up being, in this one, approximately 31. So A is not equal to H or less than H either. So it doesn't fit into any of these. However, what we said in class was we can see that this is an isosceles triangle. And in an isosceles triangle, the angles across from the two sides that are the same also have to be the same. In other words, if this is angle A and that's side A, and that makes this 70 degrees, well, then this also has to be 70 degrees. Well, at that point, you know that this is 40 degrees, and then, of course, the only thing left is that side, and there's certainly only one length that that side could possibly have. And this is not, I mean, there's nothing here in the given information that makes this impossible. I mean, we're almost done. So this is definitely one possible triangle. There's only one way for us to finish this job. Okay, now look at what it says down here. And this is if you're asking about the flow chart thing. It says here, make a flow chart summarizing this stuff, right? In other words, think about how these decisions can be made one at a time to get you through the decision-making process to lead you to one of these final conclusions. We want to know, is there only one possible? Are there exactly two possibilities, or are there no possibilities? You want a flow chart that takes you to one of those endpoints. Okay? So you can still do that in class on Monday. I can still initial it, and you can still use it on the test. Okay, so the end, although I'm trying to end this thing. Okay, see you later, guys.